Hello everybody. Thank you for attending this session despite the snow, despite the lunchtime, and welcome to the presentation around continuous packaging. So my name is Bruno Kornek. I'm working for HP. My background is around configuration management systems, around building software packages, and also disaster recovery. I'm acting as a solution architect for HP during the day and coding hard during the night. And I'm involved in a certain number of projects, either as a contributor or project lead, including some distributions such as Magia, for example. And that's one of the reasons of the interest for packaging software. So let me first try to give you an idea of the ecosystem in which we are working now. I have multiple hats myself, and as a system administrator of my Linux systems, I don't want to mess up with installing software manually. This is too cumbersome. It creates a lot of files everywhere. It's not consistent. It's not reproducible. You cannot use deployment server, etc., etc. So, and when you look at SourceForge statistics and you get the 10 most downloaded software, you see that people also tend to prefer packages, software packages for their operating system instead of using tar files or instead of trying the version from the Subversion repository or Git repository. Very few people, in fact, are using in-development software. Most of the people use stable software, packaged software that they want to test on their system, install and test on their system. When we look at developers, they are organized around a configuration management system or a version control system, call it as you want, which could be whatever at the bottom. And their main goal is to produce software. So they are organized to produce regularly tarballs that they upload to an FTP site, to a website. Very rarely upstream projects are producing packages for their own software, and which creates sometimes relationship issues between themselves and packagers, because typically they don't necessarily use the tools that the packager would like to have around the project. For example, a clean installation procedure, which is easy to use to relocate, for example, files, or to build, if you build RPM files, you know that you want to build in a subdirectory of your tree. So everything which makes it easy for them to package a software is nice, and not all projects, especially smaller ones, are organized to support that correctly. And then you have a third type of person, which is a packager for a distribution. This guy is taking, in fact, exactly the results of the software which is produced in the previous slide by the previous guys from the project upstream. And he's working probably around a configuration management system. And his goal is to produce packages and apply some conformity tools on it to check that the packages are coherent and don't contain too much errors. The issue here is that those guys may not exist at all. You have tons of upstream projects which are never packaged for distributions. And when it exists, when this guy exists or this girl exists, he or she may not want to pass all his time producing software for all the intermediate versions, for alpha, beta versions, or whatever. So he tends to concentrate on only the stable version. And that does not really help the upstream projects being tested more and being used more. So that's one of the issues that I think exist in our ecosystem. So when looking at all those points, in fact, being, taking different hats depending on the role I have during my activity around Linux, I could be either a sysadmin and I want to use only packages because it's much easier. I'm a developer of some open source software, so I want to ease my test. I don't want to mess up my laptop or my workstation by installing software in every places and then not knowing exactly what I'm launching when I'm doing my tests. So I want to install stuff cleanly, remove stuff cleanly out of my system. I don't want to duplicate efforts, and when you're dealing with packaging software, you realize that even if all the distribution may have different way of doing it, they all have the same requirements, they all need the same type of information. You need a summary, you need a description, you need an installation procedure, you need dependencies, you need a list of files that you will install. All those information are duplicated across distribution today. And an upstream project may want to centralize that type of information. I'm packaging software, so of course that topic is of interest to me. And having packages for its own software, if you're an upstream project, is very useful as a marketing activity, because you will make it very easy for your consumers to try your software. Because for them, they will just double-click on your HTTP or FTP link, and their package manager will just grab the package and try to install it on the distribution. So it makes it very easy for people to use your software and to install it. So producing not only tar files, but going up to the package level is something which is very useful for upstream projects. It's more a marketing activity because you extend potentially the number of users of your environment, and that's generally when you are developing, that's what you try to do. And there was no specific tool. When I look at it in 2005, there was, so for my own project, to give you a bigger background, I was developing and I took over the maintenance of a project called Mondo Rescue, which is a disaster recovery solution. And that project was just producing tar files for people, and it was very difficult for me to make intermediate versions for sysadmin who are not packagers, who don't want to package the software. So I made a small set of scripts to help myself, and then it became obvious that I was in need of a tool. I looked around and I didn't find anything suitable for supporting my activity. So I started to write a set of scripts, which became, in fact, this separated project called projectbuilder.org now. So for me, really, packaging should be a concern of upstream projects. It should not be only a concern of people making distributions. And there should be much more relationship between upstream projects and packagers inside the distribution. And it's even more true for smaller projects. It helps them a lot being cleaner and also having more exposure to consumers. So my new mantra is package early, package always. Really using the packaging and the packages as the only way to provide a software piece to another team. If you are in a large development organization and you have a test team, integration team, validation team, what you want to pass from one level to another is something which is already packaged, because if not, you have no traceability at all. It's really not a dream to just use packages and not install a tarball, extract, etc., and do the test like that. And the overhead exists, of course, but it's not much more long than providing a traditional tar file to your consumers. It adds a bit more because you have a bit more operation to do in the way to produce a package compared to in fact, to produce a tar file. And also, you are producing generally for the various distributions, maybe not Gen 2, but for the others, you are producing pre-compiled binaries. So you do on your side a part of the job that you don't let to the end consumer. And of course, there is a lot of benefits of doing that, because if you produce packages, you will integrate them in a repository. You will manage dependencies automatically. You will manage the versioning of packages, the tagging of packages during time. It improves the teamwork because you're delivering a pointer to repository to other teams. So integration team point to that repository, validation team to another repository, and each time you improve the software, you change just a link to the right software to use. And again, I said it, packaging is also a marketing activity, and it helps you extend your community. So as an upstream project, if you really want to be able to integrate the packaging as part of your deliveries, the approach which I would recommend is really to do continuous packaging, as there are frameworks to do continuous testing already in place. So how does it look like? So I had to put the word cloud somewhere, because today if you have an IT presentation without the word cloud, it's not an IT presentation. So consider it as a cloud. But it's a useful one. That's not a fake one. So if we think about the previous slides where we had the packagers and the developers producing information, we keep that, and the developers still produce their tarball here because that's what they are paid for or are happy to do for free. The packager is producing the same type of information, but instead of just producing one file for one distribution, it will use the tool to produce a set of files which correspond to the multiple distributions they want to support. And using those two sets of information, we can inject that in the build cloud, which is a set of virtual machines, or what I call virtual environments. So take them as shroots, build shroots typically, or remote machines if you want to do cross-compilation on other platforms that you don't have, or if you cannot use virtualization or native hosting to support the build of your software. And at the end of the operation, what you get once you have built, you get your packages for your target distribution, which could be Debian packages, RPM, Gen 2 eBuild, or stuff like that, or Solaris packages that we will see later on. And you can then push those packages once built to a repository server, which is generally the repository server of the project, and you can build automatically on that server all the indexes that are useful for RPM, YUM commands, or URPMI commands, or zipper commands, or APT environment for Debian. So to really have it working as a cloud, you need to be able also to manage correctly the systems, because you will have to create a large number of machines, virtual machines, physical machines, or virtual environments, depending on how you want to build. And you can mix and match all of them. We have in HP a tool called Linux COE, which is also an open source software under the GPL. You can download from linuxcoe.org. That tool is helping us to build initially all those systems automatically. So it's a generator of automatic installer for the various distributions we want to support. And it creates a small ISO image from which you can boot the system. And so you have all the process of installing all the system, which is taken in account by that tool. And then you can, once you have your target systems which are prepared, which are installed, you just have to set them up. So there is an operation to set up the environment in the virtual machine, virtual environment, or the remote machine, which consists in installing the client part, I would say, of the projectbuilder.org software. And once you have that ready, you can communicate between the development environment and the target system to produce the software. So when I created the software, I had some goals in mind, because I wanted to be as generic as I was in the software I was developing. So Mondo Rescue, for example, is working on a large set of Linux distributions, and I didn't want to restrict the way Project Builder was helping me building packages. So it should be able to support a large set of Linux distribution, and moreover, it could be really operating system independent. So today it supports both the RPM, deb type of build, eBuild. The Slack is still not done. And it also supports Solaris packaging, and there is an HPUX development in progress. It also supports the various repository mechanisms that exist for all the various Linux distributions, and use the tools to create the repository accordingly. It should be able also to work with different configuration management system or version control systems. I'm using it regularly with Subversion and SVK, which is a distributed version of Subversion. It works also for CVS, Mercurial, and Git. I think I have some bug to fix for Git recently, but there is no dependency on a specific configuration management system or a specific build environment. And then also we want to be able to build in a quite large or quite small environment. So at home, my desktop machine is able to build for all the distribution I'm supporting, and I have more than 100 virtual machines in a directory, and I cycle through all those virtual machines, launching them by pairs or by 3 of them at a time. And I'm building for all these virtual machines on a single system. So it could be self-contained, but you may also want to be able to have a distributed, as we said in the cloud approach, you may want to have a more distributed approach. So having a large set of machines already on your network and connect to those machines, use them as a build environment, and get back the results, which is the remote machine approach. in order to do that, so we are supporting virtual machine based on QEMU, KVM right now. For virtual environments, there are multiple tools which are working. Of course, for Debian, it's using Dead Bootstrap because that's the standard in the Debian world, either for Debian or Ubuntu-based distributions. And on RPM-based distribution, I try to use rinse and mock, but those tools are not necessarily updated regularly and do not support all the RPM distributions. So the project is also providing an RPM bootstrap command which helps you build shroots for various RPM distributions. And this one is working for Fedora, OpenSUSE, Mageia, Mandriva distributions. It's tested with those. And the goal should also be to be completely independent from the upstream project. So you can use the best usage, I would say, of the tool is probably when you are an upstream project and you want to build your own packages for your project. But you can also use the tool as a packager for a project with which you don't have a direct relationship and you are not part of the upstream community of that project. So you take the deliveries of that project, you take them unchanged, including the MD5 sum of the tarball, and you're able to inject them in the tool and build packages based on top of it. So it should be really completely innocuous around the project. It should not put any impact on the upstream project. So in order to help you, because not everybody, especially in upstream project, not everybody is able to package for different Linux distributions, so or for different operating systems anyway. So in order to help upstream project with that, when you are creating a project in Project Builder, you can have the generation of skeleton, which is done automatically. So it gives for you already a template of spec file, a template of a Debian directory, a template of ebuild file, and a certain set of macros which are also created around it to help you have something which is nearly working out of the box. So you just have to tune it a bit. Of course, you have to teach to your build system which are the files that you want to package and how is the software built. But except from that, all the structure is already provided to you to help you to speed up the adoption of the package creation. It also helps you with the creation and the management of the virtual environment to build. So typically, today when I want to add a new distribution, so each time a new Fedora version is out, I download the i386 and x86-64 version of the ISO, and I pass them to Project Builder, and I would say 10 minutes later, I have my virtual machine up and running, set up correctly. So it's really a quick process and a tooled process so that you don't have a lot to do with it. And it also provides a certain number of other nice features, such as managing the upload of your software on the repository, some mailing list announcements, etc., etc. If you are not an upstream project, if you are just a packager for a software, you may have to create patches on top of the software to make it more distribution compliant. And if you are not upstream, you cannot necessarily put those patches in the upstream tarball. So there are ways to manage the external patches that you have on top of the project. The nice thing also, in my opinion, is that those patches generally are valid for more than one distribution. In general, they are pretty useful for different contexts. So you write them once, and you can apply to multiple distributions when you are packaging directly. It's calling also the Lintian RPM lint tool if they are available to improve the quality of the packages produced. So when we deal with build environment management, when we are for the shroot approach, so the virtual environment approach, the project provides RPM bootstrap as a command, which is really modeled after Dead Bootstrap to create shroots for the different RPM-based distributions that are mentioned here. And if you are on a Debian or Ubuntu distribution, of course, it's just calling Dead Bootstrap, which works very well for that. The base work here is that it downloads all the packages from the software repository, the distribution repository. It RPM to CPIO all the software in the head of the shroot, and then it reapplies the installation of the packages so that you have a clean, from an RPM perspective, you have a clean environment in the chroot, and after that, it provides, so it gives you the list, the minimal list of all the packages that you need to launch the first command, which is a repository management command. So typically, if we say Fedora, we have the list of all the packages which are required to be able to launch YAM. And once everything is installed through RPM to CPIO, all the packages are installed again with RPM command, and then you can launch YAM install whatever to augment the content of the chroot with additional packages if you need them. And it's the same for Zipper, it's the same for URPMI, for the other RPM-based distributions. So VM and remote machines are as well supported with, and with VM you pass generally the ISO image, and you use the ISO image to install first your virtual environment. If you use a tool like Linux COE, you will get the automatic installation, so you will have no media, no keyboard attached type of installation. It will be completely fully automized. And then once you have set up your two virtual environments, either the virtual environment or the virtual machines or remote machines, there is a final setup phase which consists in installing the PB tool inside that environment. And the PB tool is a tool which is called from the outside and which is also called from the inside. In fact, from a build perspective, the project builder tool is always building natively. So if you want to build for in a virtual machine or in a virtual environment, the project builder tool outside calls the project builder tool inside the virtual machine or the virtual environment. And it is always building locally, natively. And then at the end, all the packages which have been produced are taken out of the virtual environment and brought back on the main system on which you are developing. You have the possibility to create snapshots and to manage snapshots of VMs or virtual environments. And the communication between those environments for the virtual machine and remote machine are based on SSH. So we are creating specific keys for a build account inside the virtual machine or the remote machine. And those keys are used by your environment to do automatic copy and activation of command through SSH on the virtual environment. And on the virtual machine, remote machine, for the virtual environment, as you are based on the same system, it's easy to just copy the files back and forth between the systems. So you don't need SSH for that. So here is to give you an idea of how it's organized from a directory tree perspective. You have a project which exists, and that project has its own layout. So generally you have a directory for the various projects. You have a development tree. You may tag some version and have different versions. This is more for a subversion approach of the world. And in Project Builder, if you want to be, if you want to create, the tool will create a structure which is similar to the structure of the development tree under the pbconf directory. So you will find again the development and the tag directory. And in those directories, you will have all the configuration files that are useful for Project Builder. So you will find one directory per package, which will contain one directory per type of build. And under those directory, you will have here the spec file, here the content of the Debian directory. And you may have at each level some filters that you want to apply in order to try to keep in common as much as possible information which needs to remain common. We will have a detail on the macro on the next slide. We are also managing change logs as part of the project here, which are change logs for the packages and which are used again across all package formats. So if you feel following our and there is no specific standard in the open source world for describing change logs. That's really something which is missing, in my opinion, right now. So we have again created one format here for the changelog, and from that format we can generate the format for the RPM or for the format for the deb very easily. And thus we are sharing between the packages that type of information. And the main .pb file here is a file containing all the metadata information around the project. One feature which is interesting to try to share metadata between packages is a macro feature available. So you can create for each package, you can or globally, depending on how you want to architecture it. You may want to create one macro, for example, a PV summary macro, which gives you the line, the single line that you want to put in a package to describe what this package is for. In general, in your graphical tool, when you click on the package, you will have that information written for you. So you create it once, and you specify it's a null PV filter, so it's valid for all type of systems that you want to deal with. And then in your spec file or in your control file for Debian or your PKG info for Solaris, you can use that macro each time where you need it. So the goal is really to centralize in one place the metadata that you want to manage around your software. And if you modify here the description line, either the description or the summary or whatever other type of macro you are using, you modify it once, and all your packages in the next generation will inherit from this modification and will get a coherent set of information across all the type of packages you are using. So here I show you something which generally is applicable for all type of generation packages, but you can be more or less specific. So you can create macros, for example, which are only valid across RPM type of distributions. Or you can create one macro or one information which is only valid for one distribution, one version, one architecture, if it's as precise as that. So all the possibility of macro, you can have an overloading of macro very easily. And that's a way to try to keep in central the metadata and to not duplicate information across the different packages. And if you look at the man page of the projectbuilder.conf file, you will have more information on the how to use these mechanisms. So here are the list of commands that you can pass on the tool. I don't want to detail that. It's part of the presentation you will have on the website. Some of them are mentioned here as well. So if we go back to the big picture, when you are starting, you create a new project typically. And the new project will create for you a certain number of templates for your Debian environment, or spec file, etc., etc. Some macro by default will be also created. Then you will have to add information to it. You have the project, which could be an upstream project or a pointer to a tar file somewhere on the web, depending on how you are, either if you are upstream and packaging for upstream, or if you are packaging for an upstream project to which you do not belong and you have no way to modify it. And then you can pass commands such as SBX to build, so sandbox to build, or CMS to build if you are talking directly to the CMS system. So either you have extracted from the VCS and you have a local instance for the project, and if you do SBX, it will take that sandbox version. So if you are making modifications, you do, for example, let's say we use a subversion. You do an extract of the subversion tree locally. You make modification, and you want to test those modifications. So you will use the SBX to build, and then build to package, to create packages which will contain the code that you have extracted. If you do the CMS to build, it will contain the code which is inside the subversion tree. So you have two ways to build, depending on what you want to test. But if you are making modifications locally, and that's how I'm working with the tool, in fact, I'll always do sandbox building in order to create the packages from my current modification, install them, test the modification, and once it's valid, I can update my subversion tree and push back my modifications. And so it's in two steps. The first step is creating a set of tarballs here, one tarball for the metadata and one tarball for the project data. And then once you have those two tarballs, you can call Project Builder with build to PKG to create native packages on your system. But you can also call build to VM or build to VE or build to RM to be able to build across a remote system, a virtual environment, or a virtual machine. and you will get back the packages, and they will be pushed automatically to your repository, and indexes created on the fly. And you also have a set of commands, of course, to create and set up the virtual environment and the virtual machines. So one of the so that work has been done initially on my own time, for my own pleasure, to help me build packages for another project I'm working on. But it's something which can be very useful for other usages. And typically, I have customers. I have HP customers who are building software for different type of platforms, and they really want to be able to have a single base of code. And throughout the different phases of, if we think about a V-cycle approach for the software development, which may or may not be convenient today, but if we think about it, the teams doing unit test, integration test, or validation, and up to the delivery to the end customer, my own customers are building software in those contexts, and most of them, we are interacting with them because they are existing Solaris customers and they want to migrate to Linux, so they come to us for help. And one way for us to help them is also to say, today you have a build process in place. Generally, you are not really packaging software correctly, or very few of the customers I see do the packaging correctly on Solaris, and probably because also Solaris does not manage dependencies correctly with an automatic tool such as a YAM and an APT system to compute all the dependencies and make all the installation in one shot. So as that does not exist really on Solaris yet, most customers really do a packaging of poor quality, I would say. And a way to help them is to say, if you add Linux, you will not remove what you are doing on Solaris, and you may work on Solaris Spark, you may work on Solaris x86. You will not remove those developments in one day. You will keep maintenance for a very long time. I'm working with telco customers. Those guys tend to have projects living for more than 10 years. So they need to have an infrastructure which is in place and still working, and they need to add Linux as a development track in their environment. And using a tool like that is a way for them to introduce a better packaging on their Spark or x86 Solaris environments, as well as supporting better the packaging on Linux, which is a new track for them. And if we introduce these practices very early in the life cycle, it helps them a lot producing and controlling more finely the production of software to their customers, which is always a concern for telco customers. We have done a white paper on this for our own customers, which is available on the web. And if you look at it from a multi-target perspective, multi-platform perspective, in general, those customers looking at, we have an existing software on Solaris and we want to add Linux to the picture. They have a very strong set of files if they are developing using C, C++ type of code, which is the majority of the telco environment. Those guys have a large code base which is unchanged, in fact, when they are migrating to Linux. The number of files, the number of functions that needs adaptation exists, but it's not a large one. So they really have to map what does not exist on Solaris onto Linux, and they can package their software in a way. It's also helping them keeping the core common for a long time, and again, do not duplicate the information and share that information across the various branches. And the tool helps them build different packages for different platforms using that split of software. What I can do is I can show you a small example of how it works concretely. So So bear with me. My machine is an Atom laptop. It's not very quick. At home, I have a Xeon-based system, which is showing 12 threads on the system. Here, I just have one core. So the build is slower than what you are probably experiencing on your environment. So what does the tool? Here, I ask him to build from the sandbox and to build packages directly. So the warnings that you see are coming from SVK, not from the software itself. So it tries to identify which is a project, what action it has to do, and which are the packages it needs to build for. And then for each of the software bricks I want to build, so I have 4 packages here identified in my build environment. It will first do an export for each of the bricks. It will do an export from Subversion, so my local Subversion SVK, into a temporary directory. It will deal with the changelog, and it will prepare the delivery. So here it's quite long because so the tool is parallelizing. If you have a multi-core system, here you will have a very quick work, because at that point it's generating all the build information for all the distribution I am supporting. So it's generating more than 100 set of files for all the distribution I'm supporting. So it takes a bit of time on that Atom system. It will do it 4 times. Potentially it will apply patches if there are patches, but here I'm upstream, so I don't have patches to apply. And it will create for me 2 tar files. One tar file for the upstream project that I can also push to my FTP server if I want people to use that. And another tar file for the configuration, the build files, in fact, all the metadata. So if you look at it, for example, in another window, so you will see that this tar file, in fact, and that's what was long to generate, contains a certain number. So everything will be put in a specific subdirectory alongside your project information. And then for each distribution I'm supporting, it will create one subdirectory, which is a tuple, which is, the name of the distribution, the version of the distribution, and the architecture on which you're working. And then under that subdirectory, you will find everything that distribution needs to build the software. So a spec file, if it's an RPM, if it's an Ubuntu, like here, you have different files, such as the control, rules, some docs or whatever, compat files, changelog, etc. So the changelog, for example, here is generated from the changelog which is in the project. And so here you have a certain number of various distribution for which it's building. And then afterwards, so if I go back to my other window, so it's still not done here. So it has done that for the first one, second one, there's a third one, and then afterwards it will call. So here I'm building locally, natively on my laptop. So I have shortcuts. Here I do it like that to show to you that the conf file contains everything. Normally when I build it on that machine, I just restrict the build for my local system in order to avoid to wait 5 minutes each time, because on this system it's quite slow. And once all the tar files have been created for all the packages, then it calls normally, the next one, it will call the build of the packages locally for the distribution. So here I am on a Mageia distribution, so it will call RPM build using the spec file which is from the local. But all those tar files contain everything in a single instance, everything which is needed to build for 100 different distributions. So I can just pass those files along into my virtual environments, my virtual machines, and I will get in it everything I need to build for the local distribution I'm building for. Okay, so once it has created all my 4 tar files, then it creates packages, the 4 packages I am asking to create. Then it's extracting the spec file from the pbconf tar file, because it knows it's an RPM-based distribution. And then it's calling the RPM build for each of the packages. It applies patches if there are patches to apply, which is not the case because I'm upstream. Potentially source files from additional source files if there are additional source files. It could be either patch files or source files. And then it builds at its turn each of the packages. So software is written in Perl. It takes also in account, well, we have lost it. Some rules, naming rules. For example, the Perl build of packages is really specific on Debian and on RPM systems. There are certain rules, so the tool is also able to apply those rules to have a Perl dash something name of packages on RPM-based system or lib something dash Perl on Debian. It takes into account that type of stuff. It can also sign packages. So here I don't have my keys on that laptop, so I'm not signing, but it tries to call the signature system. Then it calls the RPM lint, which is not working here in my environment because I have a special character in one of the files, which makes it fail. And it builds for me a certain number of packages which are mentioned here. Source packages, RPM packages. I have the list. I can just pass sudo urpmi of that line, and I will have the installation of those packages on my system. So that's how I'm testing the software myself. And here I'm working on the development version of Project Builder. So this is the development branch, and the tagging mechanism put in place is also done by Project Builder automatically in order to help with the tags. It's easy to install a new version because it's based on the date. So each time the tag will increase, you will be able to do that command. It will not cause any problem. And once you have the final version, anyway, it will not be the same tag nor the same version. Now, I've done that natively. I can do that. So I will not restart from the sandbox because I already have built my tar file. So I will start from the build environment. And this time I will build to a virtual machine, which is, for example, CentOS 5 i386. So it starts from the fact that it already has the tar file, and this time it's moving all those sources into the virtual environment, and it's calling a script in the virtual environment. So the shroot, which is located here, RPM bootstrap CentOS 5 i386. So this is my major shroot, and then it's calling. Okay, so maybe we can go back a bit to explain that. So then it's calling Project Builder inside the shroot, and inside the shroot, Project Builder is building again RPM packages, but this time for CentOS system. Then it gets the packages from the shroot environment. It tries to sign them, which it still cannot do, but it could on my real build system. And then it does a local, so here I'm doing a local delivery. So all those packages are sent into my home FTP test environment. So I have a local FTP server that I am populating with the content of those packages. And I can execute also, okay, so the create repo is, so I'm moving to Mageia. Not all the tools are yet available on Mageia to build for all the other distribution, because the interesting topic I have to solve is that I need to be able to launch Debian tools on Mageia, Fedora tools. Of course, the native tools are working, but once you have chosen one distribution, you also need to provide all the other build tools available for the other distribution as well. And so this one is not building correctly the create repo stuff, but if we look at yeah, no, that's this one. So here, if I go up, I just built for CentOS 5. So here, this is a local also. This is my FTP server locally. And I can see that I've just built normally 930. No, they're not shown here. Strange. Okay, so the packages are correctly uploaded just at the time expected in the directory. So you have I have my sets of 2 source and binary packages for my my environment. I don't know why the browser does not see them. And of course, I can also build now for something more interesting. So I have also a shroud for the Ubuntu 11.10 available. And so because here I've just shown to you to build just RPM packages, which is already interesting, but not sufficient in my opinion. So the goal is really to build for different type of environments. And here we are building for an Ubuntu distribution. So the same, we are passing all the files required in the shroud environment here, calling Project Builder inside the shroud environment. So it's building the packages, and once it's done, it will provide to me the set of packages, and also try to call the tool to build the APT repository, which won't work on that version because they are not yet available. Any question? Yes.
So please use the microphone and raise a question so that people from abroad may hear the questions.
So the question is there a Mac or a Windows built root somehow?
Not yet. Not yet, because I don't have any Mac. I'm working for HP, so it's a bit difficult. It's a politically difficult topic. So I don't have a Mac, and I'm not interested by Windows. So that's another problem. So I mean, in the way the tool is designed, there is nothing preventing you to do it. Now, I need information, I need input from people for who it's really important so that I can put the right entry in the software and make it available. But, okay, so this time it asks me to, well, I would just cancel it because I don't want to read that part. So yeah, why not? The mechanism are similar as long as I can communicate with a Windows machine through an SSH mechanism, which is available, same for the Mac. And so the software is written in Perl. There is, I'm really cautious about not having external dependencies as much as possible. So I just rely on 3 Perl modules on top of what Perl provides in 5.8. And I try, because I want to keep also compatibility with very old type of environment to build for stuff which are ages old. I want to reduce the number of dependencies as much as possible to be as portable as possible across different environments. So it should be fairly easy to adapt it on Mac and Mac OS X and Windows. Okay, so here I have the call to the dpkg scan packages, which is working, but not to the FTP archive is not working. But I got my my packages, and if I go into my directory where I'm uploading So I can see that I've just uploaded my content for Debian packages here. Any other question?
Why do you use custom chroot initialization for Fedora, the RPM Bootstrap, when there is native chroot initialization called mock? And you are aware of mock?
So you can call mock. The stuff with mock is a bit limited compared to what I'm doing with RPM Bootstrap. Mock is, the last time I tried it, and it's quite some months ago, I must confess, but the last time I tried it, it was not able to work with OpenSUSE, nor with Mandriva correctly.
Sure, it is only native for Fedora, but when you are building for Fedora packages, I think you can use mock.
There is no problem. You can call mock. I have entry points for mock as well as for RPM Bootstrap, as well as for rinse. Rinse is a bit more portable than mock, but it has not moved a lot recently as well, so it's not supporting correctly the latest version of distribution as well. So, but you can use mock if you prefer. No problem with that.
Hi. You said that Solaris is missing a tool for automatic dependency tracking and installation like apt. May I point your interest to pkgutil from the OpenCashew project, which does exactly that for Solaris?
Okay, good. So now I need to point my customers to that tool, because that's more useful for them than for me. But okay.
For porting to some new platform, which are the files I need to touch when I add support, say, for AIX?
That's a good question. So you need to look at the source code for Project Builder, and you need the best way would be to look at the Solaris entry points and to create branches for AIX, similarly to what has been done for Solaris. Or there are some entry points for HPUX, but it's not completely supported yet. And there are not a lot of aspects to do. The major one is how to package for that platform, that operating system. So there is a point where you call the right tool, which is in charge of building the native package, and that's the section you really need to develop for AIX. For the rest, it's much more a matter of a certain number of configuration files. So I've not shown to you, but most of the software is working through configuration file and not through. I try to avoid to hard code too much stuff. So, for example, you have the way to detect automatically the distribution on which, or the OS on which you are working is mentioned here. You have if you want to do it for AIX, you would have to create a hierarchy like that of information, which could be very simple for AIX because you may not have as many sub categories as we have for Linux typically. Then you need to create a type which is associated to that new operating system, which is generally the name of the package format. And then there are a certain number of commands to deal with updates and stuff, installation of packages, extensions that you want to use. And then, for example, for RPM Bootstrap, here you have the minimum set of packages that needs to be installed in order to have a working chroot environment, but that may not be what you want to do first, anyway, for AIX.
Okay, given the platform support is done in principle, what do I need to touch in the package definition to support the new platform?
So in the package definition, what you would need to add is generating a template, a skeleton of build file for AIX. So typically, Project Builder, when I added the support for Solaris, when you create a new project, it will automatically create a pkg info for you. So you would have to create also the basic template for an AIX build with the right macros in it. and that will be used by the section of the tool which called the build for your specific format. But we can discuss that maybe more offline, because it's not necessarily easy to explain.
But this is necessary for each package to be done.
It's necessary for each package type to be done. So once you are able to build for AIX, whatever application you want to build for AIX it will work out of the box. But what you need is to support a new package format and a new package type. So you need to provide those information for it. But Solaris, it took me 2.5 days to understand how Solaris packaging was working with a background of Linux packager, and it took me half a day to add the code in it to make it really work. But it's much more understanding how a new operating system is packaging software, and generally that's where you have. If you're used to that, that's a good point, because that's where I need to ask questions in general.
I noticed that there's quite a big overlap between Project Builder and what the Open Build service does. With building for multiple distributions, publishing repos, and such. Are there plans to cooperate somewhere, share tools and things?
Why not? I would say the problem is the code base is not written in the same language. It makes probably exchange a bit more difficult. And